Chapter 1, Describing the Physical Universe. On June 21, 2004, Spaceship One became the first private aircraft to leave Earth's atmosphere and enter space. What is the future of this technology? Private companies are hoping to sell tickets to adventurous people who want to take a trip beyond Earth's atmosphere. Our study of physics can help us understand how such a trip is possible. Many people, when asked the question, "What is physics?" respond with, "Oh, physics is all about complicated math equations and confusing laws to memorize." This response may describe the physics studied in some classrooms, but this is not the physics of the world around us, and this is definitely not the physics you will study in this course. In this chapter, you will be introduced to what studying physics is really all about, and you will begin your physics journey by studying motion and speed. Chapter 1, Section 1. What is physics? What is physics and why study it? Many students believe physics is a complicated set of rules, equations to memorize, and confusing laws. Although this is sometimes the way physics is taught, it's not a fair description of the science. In fact, physics is about finding the simplest and least complicated explanation for things. It is about observing how things work and finding the connections between cause and effect that explain why things happen. There are three basic aspects of physics. The first aspect of physics is describing the organization of the universe. The universe is defined as everything that exists. Everything in the universe is believed to be either matter or energy, as shown in Figure 1.1. Matter is all of the stuff in the universe that has mass. You are made of matter, and so is a rock, and so is the air around you. Energy is a measure of the ability to make things change. Energy flows anytime something gets hotter, colder, faster, slower, or changes in any other observable way. A second aspect of physics is understanding natural laws. A natural law is a rule that tells you how or why something happens the particular way it does. We believe that all events in nature obey natural laws that do not change. For example, one natural law tells you a ball rolling down a ramp of a certain height will have a certain speed at the bottom. If the same ball rolls down the same ramp again, it will have that same speed again. Physics is concerned with understanding the natural laws that relate matter and energy. A third aspect of physics is deducing and applying those natural laws. A third important part of physics is the process of figuring out the natural laws. The natural laws are human explanations based on human experience. A ball will still roll down a ramp regardless of whether you know why or how. It is up to us to figure out how and why. This part of physics often uses experiments and analysis. An experiment is a situation you carefully set up to see what happens under controlled conditions. Analysis is the detailed thinking you do to interpret and understand what you observe. Both of these activities lead to the development and refinement of natural laws. You will learn many natural laws in this course, but we don't yet know all the natural laws. There is a lot left for us to learn. Let's talk a little bit about matter and energy. Matter and mass. Matter is defined as anything that has mass and takes up space. Mass is the measure of the amount of matter that makes up an object. A car has more mass than a bicycle, but why does the car have more mass? The answer is that the car contains more matter. Steel, plastic, and rubber are different forms of matter, and the car has a lot more of it than a bicycle. Is air matter? How can you tell if something takes up space? Does the air around you take up space? Think about how you could test whether or not air takes up space. An empty glass contains air. Imagine a cylinder you could push into the empty glass. If the cylinder formed a seal so that the air inside couldn't escape, you wouldn't be able to push the cylinder all the way to the bottom. Why? Because air is matter and takes up space, as shown in Figure 1.2. You don't always notice the mass of air because it's spread thinly, but the mass of air in an average classroom is about equal to the mass of one student. What about light? Is light matter? Just as an empty glass is actually filled with air, it is also filled with light in front of a window. Is light a kind of matter? Because light does not take up space and has no mass, it does not fit the definition of matter. Imagine pumping all of the air out of that empty glass while the cylinder is pulled back. Even if the glass were near a light source and filled with light, you could push the cylinder all the way down because light does not take up space, as shown in Figure 1.3. The glass also has the same mass in a dark room and a room full of sunshine. Later in the course, we will see that light is a pure form of energy. So let's talk about energy. Imagine dropping a stone. In your hand, the stone is described by its mass and height off the ground. Once it is falling, the stone speeds up and its height changes. If you investigate, you learn that you cannot get just any speed by dropping the stone. You cannot make the stone go 100 miles per hour by dropping it only 1 meter from your hand to the floor. But why not? What limits how much speed the stone can have? The answer is energy. Energy is how we measure the amount of change that is possible. Changing the speed of the stone from 0 to 100 miles per hour takes a certain amount of energy. Lifting the stone up, changing its height, also takes energy. Change takes energy, and the amount of change you can have is limited by the amount of energy available. Now that we've talked a little bit about physics and matter and energy, I would like you to do a short homework assignment. So create a Google document with the following title: Block, Last, First, Chapter 1.1, Response 1. And then I want you to respond to the following prompts in 2 to 3 complete sentences. Always and forever, for the rest of your life, on any assignment you do for me or any other teacher, use complete sentences. I would like you to respond to, what questions do you still have based on the reading? Was anything confusing? In your own words, distinguish between matter and energy. And what, if anything, did this reading change about your perceptions of physics and science? Share it with me, and it's due before the next time I see you in class.